On this slide, we see the relative positions of the mean, the median, and the mode, and what they mean in terms of the symmetry of the distribution. In other words, what is the significance of knowing where the mean, the median, and the mode lie with respect to each other? And the answer to that is for knowing the symmetry or skewness of a distribution. The relative positions of the mean, median, and mode of a distribution can indicate whether a distribution is symmetric, which is the same on each side, or if it's skewed. When the mode, median, and the mean are all equal, the distribution will be symmetric and will have a skewness of 0. This is depicted in the leftmost graph. For this symmetric population, the number of years corresponding to the highest point of the curve is the mode, 20 years. Because the distribution is symmetrical, the median corresponds to the point where the distribution is cut in half, 20 years. Logically, any of the three measures would be appropriate to represent the distribution's center. If the mode is less than the median, and the median is less than the mean, the distribution will be positively skewed or skewed to the right. In a positively skewed distribution, the arithmetic mean is the largest of the three measures. Why? Because the mean is influenced more than the median or mode by a few extremely high values. And finally, if the mode is larger than the median and the median is larger than the mean, the distribution will be skewed to the left or negatively skewed. We note that when the distribution is negatively skewed, the mean is the lowest of the three measures because it is influenced by extremely low observations. If the distribution is highly skewed, either negatively or positively, the mean would not be a good measure to use. The median or mode would be more representative.